All right, welcome back, Algebra 1. At this point, we are professionals at using the Pythagorean Theorem, right? A squared plus b squared equals c squared. And last time we saw how we could use that when we have a graph that's drawn. We can actually use that to find the distance between two different points on a coordinate plane. The way we do that is we have to think about this as a right triangle. And this side was 1, and this side, when we count it, was going to be 9. All right, so because it's a right triangle and we know those two sides, we can figure out what the missing side is, what that missing length is. So we just use the Pythagorean theorem. It's an addition problem. So we did 9 squared plus 1 squared equals square rooted. And when we did all that, we got 9.06. So the distance between these 2 points up here, that missing distance was 9.06. All right, now let's do another one. Except this time we're not going to graph it because the graphs are great if those points are pretty close, but what if they're spread out? What if you have to make a graph that uses like 100 or negative 250? You're not going to want to graph that on a graph. So we're going to have to figure out some other way to do it. Let's actually come back up here. Let's come back right here and let's look at these ordered pairs for just a second. Let's look at the points that we were given and see if we can kind of figure out a pattern here. So this point over here is the point 4, 0. And this point back here is the point negative 5, 1. Okay, so let's compare the ordered pairs that we have with the numbers that we used down here. First of all, look at the negative 5 and the 4. I got a question. What happens if you take negative 5 minus 4, or maybe even a little bit easier, 4 minus negative 5? Maybe that's what I'll write up here. What is 4 minus negative 5? So we had the two numbers and we subtracted them. 4 minus negative 5, well, if you go minus negative, that's plus positive, right? That's just going to be 9. What happens if we do the same thing with the 1 and the 0? What happens if we go 1 minus 0? That's going to be a 1. And look at the two numbers that we had there, 9 and 1. So actually, this is actually going to work for us. If we don't want to graph out those points and count the squares, we can just subtract the coordinates. Take x minus x and y minus y. And then that gives us a number, right? The x minus x gave us a 9, and the y minus y gave us a 1. And then all we have to do is take that 9 squared plus the 1 squared equals square rooted, and bam, we've got it. And if you followed me, you just came up with a really kind of complicated looking formula called the distance formula. That's a distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, let's not get freaked out about how difficult that looks. All we're doing is, this first part just means subtract your x's. Find out the distance between those 2 points. And then what are you going to do when you have that number? Once you know what that side length is of that triangle, you're going to square it, right? Boom, square it. And then we're going to come over here and we're going to figure out, so we already figured out how far over it goes. Now let's figure out how far up and down it goes. What's the change in y? y2 minus y1. And when we know what that side is, what are we going to do? Pythagorean theorem, we just square it, right? Down here, we used the 9 squared plus the 1 squared, and then took the square root of it, and we found our distance formula, okay? Let's actually start doing these a little bit. And if you want to write out the whole distance formula, that's great. I'm not going to. The Pythagorean theorem, I'm just going to work it in my mind. So what's 2 minus 8, or 8 minus 2? It doesn't really matter for this one what order we go in. 8 minus 2, that's just going to be 6. And what's 14 minus 6? 14 minus 6 is going to be 8. So all we have to do is 6 squared plus 8 squared. Whoops, 8 squared equals square rooted. Because one side of our triangle is 6, the distance between the 2 and the 8. The other side is going to be 8. So we've got two sides of our triangle. Let's just figure this out. 6 squared plus 8 squared equals square rooted. And that's going to be 10. The distance between these 2 points is 10. Let's look at the next one. All right, let's just find the distance between the x and the y. So let's go 4 minus negative 17. Minus negative is going to be plus positive. So that's just like 4 plus 17. That's just 21. And 25 minus negative 3. Now notice, I went in a different order that time. This isn't slope. With slope, you have to find the order you have to keep them in the correct order. With distance, we don't need to. I just want to know the difference between those 2 points. That's it. 25 minus negative 3 is going to be 28. So let's square them and add them together, and then take the square root of it and see what happens. 21 squared plus 28 squared equals square rooted 35. The distance between those 2 points is 35. So that's all it is. I know that that is a big, crazy, complicated looking formula, but really it's not going to be too bad, because remember, just in your mind, just I'm gonna throw my thoughts over here in blue. Just know that you've got a point somewhere and a point somewhere, right? So you have to figure out, the first thing is, what's the difference in those x values, right? Then you're going to take that, you're going to figure out what's the difference in those y values. When we square the x values and square the y values and take the square root of it, that's the Pythagorean theorem, and that's going to tell us what the difference is, okay? So it looks big and crazy and complicated, but really all it is a plain old straightforward Pythagorean theorem. All right, I know you can do this. Good luck.